Today, we are going to work through an example case study using SPC control charts. If you don't have the basics of control charts yet, I recommend watching the video highlighted in the corner first. Since today is a practical example, I will assume that you already have some basic knowledge of control charts. So let's get started. Our case study takes place in a manufacturing company, and here's the background. A manufacturing company wants to reduce the time between a machine breakdown being reported and the maintenance team responding to the issue. To improve performance around 20% in average, the company implemented several process changes, including enhanced communication procedures and revised maintenance escalation rules. To evaluate the effectiveness of these improvements, response time data was collected over a period of 180 consecutive days. 90 days before the improvements were implemented and 90 days after the improvements were implemented. The response time in minutes for each breakdown event was recorded and summarized as the daily average response time. The company would like to determine two things. First, whether the process performance improved compared with the baseline period. And second, what additional data would be required to draw clear and reliable conclusions. In this study, our task is to use appropriate control charts and statistical analysis to assess the impact of the improvement initiative and to provide recommendations based on our findings. And here's the data set we have been given. 180 days in total, 90 plus 90, before and after implementation. You can find this data set in the description below. Now, let's use SigmaDesk's control chart builder to evaluate the collected data. You can also sign up for free and follow along with me. The link is again in the description. First, we need to pick the right chart. Since we have continuous data with just one value per day, the natural choice is an IMR chart, that is, an individuals and moving range chart. The individuals part tracks the response time itself, and the moving range part tracks the variation between days. With 90 days before as our baseline and 90 days after, the chart will tell us whether the changes made a real difference or whether what we see is just normal noise. So I go with the IMR chart. I then paste my dataset into the spreadsheet below, and my control chart is visualized. It is actually not easy to see any improvement immediately. We have two violations outside the control limits at these points, but by themselves, they do not tell us much. Also, in the moving range chart, I see the same violations. For now, we cannot draw any conclusions about improvement or identify any specific findings. Let's delve a little deeper into the chart. Let's start by separating the data into stages. I split the control chart into two stages, before improvement and after improvement. So from the 91st day onward, there is a separate control chart view with its own separate control limits. So what did we get? Actually, the average have not improved between before and after noticeably. Looking at the variation in the upper control limit, I could even dare to say they got slightly worse. I will check the Western Electric Rules tab to see if any special pattern is being signaled. And here again, there is not much to note. We only see what we already know, 2 Rule 1 violations. That simply means points outside the control limits. In our case, above the upper control limit. I will show you another trick now. Points that fall outside of 3 sigma, meaning outside the control limit, often have a special cause. I don't know exactly what went wrong on these particular days, but I will exclude these data points for now. It is day 98 and day 153, so for now I will exclude them both. I do this simply by marking a star on each of them. Another way would be to exclude them in the settings using data exclusion filters, like excluding below or above a specific value, but since there are only a few, I will do it this way. Now I have a few suspects, but let me go back to the Western Electric rule signals with you one more time. And here, Rule 4 has been signaled 14 times. This rule gives a signal when 8 or more points stay on the same side of the center line. In our case, they were on the lower side and it happened 14 times. So for 14 days, the response time stayed below the center line. That is a strong statistical signal of an improvement. and it is not something that can easily happen by pure randomness. We can actually see it here. Previously, we were not able to see this pattern because that special day was disrupting the data pattern and this special pattern was not signaled. So we used violation 1 and excluded it to be able to identify another special pattern. Now I will add another stage covering the first 15 days after the improvement. Everything becomes much clearer. We can actually talk about a real improvement right after the changes were implemented. But the real problem is sustainability. So the conclusion here is that the process did improve after changes by around 15%, not 20%, but still something. But the improvement could not be sustained. This could be a standardization issue. Perhaps the improvement was never translated into a standard way of working, and the team went back to their previous routines. And coming back to the question of whether we need more data, yes, we do, especially for the data points we excluded. There could be a special reason behind those days, for example, more maintenance activity than usual, or a shortage of staff. So let me wrap this up with a short summary. We learned 3 things. First, the maintenance response time really did improve by around 15% right after the changes were made. Second, that gain did not last, which points to a sustainability problem rather than a problem with the improvement itself. And third, the most likely cause is that the new way of working was never standardized, so people slowly drifted back to their old habits. And that is really the power of a control chart. It does not just tell you whether something improved, it tells you whether the improvement actually lasted. If you would like to try the same analysis yourself, you can do it on SigmaDesk, and the link is in the description below. If this was helpful, please subscribe for more practical SPC and Six Sigma examples, and I will see you in the next one.